Hi class, today's lesson is 6-1 in your textbook, titled How to Use Similar Polygons. We talked a lot about congruency. Now we're just talking about what makes different polygons similar to each other. So here I have two different polygons drawn, and as you can tell, they look very similar. The shape of them, the angles, it's just that the sizes of their lengths are different. So similar polygons have two things in common. They have congruent corresponding angles, which is what you can kind of see. Like it looks like angle D and angle H are both about 90 degrees. And if I measured these, they would all be exactly the same. A and E would measure the same, B and F, and also C and G would measure the same. The second part is that they have proportional corresponding side lengths. Okay, so what that means is that when I make a ratio, when I compare one side to another side by dividing them, it's going to be the same ratio that I get if I divided BC divided by FG, or CD divided by GH, or AD divided by EH. All of those would give me the same ratio, the same number. So in this case, I would say that ABCD, that polygon is similar to EFGH. This sign right here is what we're going to say for similar. It's just one little squiggle, a little different from congruency. And so based on what I have, if I was going to write down all of the corresponding angles, knowing that these were similar polygons, I would say that angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. Okay? If I was told that they were similar, these are things that I can assume right away, that the corresponding angles are congruent to one another. And then also we were talking about corresponding sides and how they will be proportional to one another. So if I had the first side AB and I wanted to relate it to the other polygon, I would say that that relates to side EF. And so I'm going to divide them. And when I divide the lengths, it's going to be equal to, if I divided BC by the length FG. Likewise, it's going to be the exact same ratio of CD divided by GH, and also AD divided by EH. Okay, so all four of those, if you divided them, you would be able to get the exact same ratio every time. So we're going to go ahead and I'm going to show you an example. You're given that triangle ABC is similar to triangle DEF. And so I want us to do a few things. The first thing that I want us to do is to list all of the pairs of congruent angles. Okay, that's the first thing that I want us to do. So in the order that it's written is the order that you're going to write the angles that are congruent. So angle A is congruent to angle D. Okay, B is congruent to angle E. And lastly, angle C is congruent to angle F. So this is the first part. Pretty easy. If I was going to measure them, then I would have found that they were exactly the same measurement. Okay. The second part that it's asking me is to check that the ratios of corresponding side lengths are equal. Okay, so this is where we're going to do a little bit of math. So the first one that I'm going to check is AB, that length, compared to DE. And the length of AB is 25. The length of DE is 35. And when I simplify both of those by dividing by 5 on top and bottom, I'm going to get the fraction 5/7, or the ratio of 5/7. Let's see what else we can compare. BC to EF. BC to EF. So one thing that I want you to notice is that the first one that I choose was from ABC, so the first one I choose again needs to come from ABC. Okay. So BC measures at 20 and EF measures at 28. And when I divide both of those by 4, I'm going to get the ratio 5/7 again. And so you guessed it, when we do the third one, AC compared to DF, I'm going to get the same ratio. That's going to be 30 over 42. Divide both of those by 6, and I get 5/7 again. So I can see that all three of those corresponding side lengths are equal, that those ratios are the same. So when it asks us to write the ratios of the corresponding side lengths in a proportional statement, now that I know that they all equal 5/7, I can write AB divided by DE is going to be equal to BC divided by EF, which is also equal to AC divided by DF. Now I can't write this if I didn't actually figure this out, because if one of them was different, I would not be able to write this proportional statement. So the last thing that I want you to notice is that the ratio of lengths of two corresponding sides is called the scale factor. So this 5/7 that we found up above, this would be called the scale factor of these similar triangles. Okay? So let's move on. I have another example for us. This time it says that triangle DEF is similar to triangle MNP. Okay? So what it wants you to do is to find a missing element. This case, it's the element X, all right, one of the sides. So the way that we're going to do this is write out those proportional statements to figure out the missing side. So what I can do is I can compare DE to MN, which should be equal to EF compared to NP. Okay, so DE we found was 9, and MN is 12. So 9 over 12 should be equal to EF is our X that we're solving for, and NP is 20. So if I do cross multiplication, okay, 9 times 20 is 180, and 12 times X is simply just X. And when I divide both sides by 12, I'm going to find that X is equal to 15. So the missing side is 15. And you did not have to choose the DE compared to MN. If you wanted to do DF over MP, which would be 12 over 16, you could have done that here as well. And you would have had the same exact number for X is equal to 15. Okay? So let's talk about a theorem now. This is theorem 6.1, and it's titled Perimeters of Similar Polygons. And what it says is that if two polygons are similar, so that's something that you're given in the very beginning, then the ratio of their perimeters is also equal to the ratio of their corresponding side lengths. So if I was able to find just the ratio of their corresponding side lengths, it would be the same as if I compared the whole perimeter of KNLN compared to the whole perimeter of PQRS. Okay, so if those two polygons are similar, okay, then finding the perimeter of the first one and relating it to the perimeter of the second one by adding up all of those sides, it's actually going to be the exact same as simply KL compared to PQ, which is going to be the same as LM compared to QR, which would be the same as MN compared to RS, and also KN compared to PS. Okay, so it's kind of a cool thing that the perimeter would be pretty much proportional to the side lengths, comparing them as well. So another fact that I want you to know is that if two polygons are similar, then the ratio of any corresponding lengths will also be equal to the scale factor. So it's not just the perimeter. There's other lengths that we might find in some diagrams. It might be the altitude, It might be the median. So there's many things. In this example that I'm going to show you, it's actually going to be the altitude. So we're given that triangle TPR is similar to triangle XPZ. And we're asked to find the length of the altitude PS. So let me show you what this diagram looks like. Okay, it kind of looks like a bow tie in a way. And we're wanting to find the altitude. So this actually is not that tricky. What we need to find is the scale factor. So let's do that first. So find the scale factor. And because I'm given some information but not a whole lot, I'm going to use the information that I have. I have what TR is, and I also have the length X to Z. So TR is 6 plus 6, and XZ is 8 plus 8, so that's 12 over 16, which simplifies to 3/4. So the scale factor for both of these, when I compare them for any length, should be 3/4. So now that I have that, let's compare some different sides that we know. For instance, we know that PS, which is what we're looking for, should compare to PY, to the other altitude of the second triangle. And we know that that should be equal to 3/4 to the scale factor for the whole triangle. And I know that PY is 20, so I'm just going to I'm going to substitute that in. So PS divided by 20 is equal to 3/4. I'm going to do some cross multiplying. So 4 times PS is equal to 60. And when you divide both sides by 4, we're going to find that PS is equal to 15. So there you go. I found the length of the altitude of the smaller triangle, and I'm done. So I have one problem for you to do on your own that I'm going to show you right now. You're given that triangle JKL is similar to triangle EFG, and I want you to find the length of the median KM using the same technique that we did in the example before. So try to solve that on your own. Come with any questions that you have to class, and I'll see you then.